So in this video, I want to talk about number systems and binary numbers. So a number system is just a particular way of counting. And normally what we do is we count in decimal. In our everyday life, we use the decimal number system. And that includes the set of numbers from 0 all the way to 9, right? And when you get to 9, you roll up to the next spot, and we call this 10, right? And for logic design, what we need to do is we need to use another number system, and that number system is called binary, and it only consists of a 0 and a 1. So this is this is the entirety of the number set, and the goal is to figure out how to um, represent decimal numbers that we use in our everyday life in binary with only 2 digits. And so we're gonna talk about how to actually convert from the decimal number system to the binary number system. And it's very easy. So what you do is we start off with a number. So as an example, we can do 9. Um, so we have 9, and we write a little subscript 10 there, just so we know that we're in the decimal system, the decimal number system, and we want to convert that to binary, and which is just a string of ones and zeros. So you have to think about it like you're encoding another number inside of this binary number system. And to do that, we simply divide by 2. And the 2 is this is the base, and a base. This is kind of an aside, but in a number system you have bases, and so in decimal we have a number like 835 is 800 plus 30 plus 5, and we can reduce this further by saying 8 times 100 plus 3 times 10 plus 5 times 1. And we can actually reduce this even further, which is the pretty cool thing about it. You can actually reduce these numbers and you get 8 times 10 to the second plus 3 times 10 to the first plus 5 times 10 to the 0. And so in algebra we call the this number right here the base, and this number right here the exponent. So in decimal, we're in base 10. That's what you call it. Well, that's another name for it anyway, is base 10. So that's what this number right here indicates, is that we're in base 10. And for binary, this base is actually different. So this base would be a 2 instead of a 10. And so now you kind of have an understanding of why we're using a 2 here in this method. And really this method just consists of taking the number in decimal and dividing it by 2, and you end up with a binary number, a binary digit, otherwise known as a bit. And what we do is we keep dividing until we get the full number. So it'll make more sense when you actually see it. So we take 9 and we divide it by 2, and so 2 goes into 9 4 times, and we get a 1. And now this actually goes into the ones place of our binary number. So it's analogous to it going in the ones place here, like where the 5 is. That's where it goes. So we write a 1 and base 2, and we take 4 now. We take 4 and we divide that by 2. And we divide that by 2. So 2 and 4. And 2 can go into 4 2 times, and we get 0. So now we take this 0 and put it in the next spot. So now we have 0, 1 in base 2. We're not finished. We're only finished when this number up here is actually 0. So we're going to take 2 and divide it by 2 again. Divided by 2. And 2 can go into 2 one time, right? 2 minus 2 is 0. And now we take this 0 and we put it in front of this other 0. And now we take this 1, because remember, we have to keep going until we have to do this process until this quotient up here is 1, right? So we keep going, and we do 2 and 1, and 2 can't go into 1, right? So it goes into it 0 times, and now this is your indication that you're finished, right, with this process. This means to stop, all right? And now we get a remainder of 1, and this actually goes there. So now our finished final product is 1, 0. That was a bad box. 1, 0, 0, 1 in base 2. And this is the same as 9 in base 10. So now you've got a good example. In the next video, I'll do some more examples of conversion, and hopefully it'll start making sense.